Right. Hello everyone. I am going to go through the first question, which is on your screen. So that's number 1, A. Right. So f maps x to. So this arrow here is the maps to arrow. It's not just a random symbol. It's an actual mathematical symbol, and you use it in this situation. The function f maps x to, and then what is it, 5x add 1 over x squared plus x minus 2, take away 3 over x plus 2, and we've got the domain x's or real numbers greater than 1. So that's going to be important. Okay, so first of all, this is just a long-winded way. This whole thing is just a long-winded way of just writing f of x equals 5x add 1 over x squared plus x take away 2 take off 3 over x plus 2. And the question's wanting us to write it, well, just as one fraction in its simplest form. So what we're going to do is, well, we've got two fractions being subtracted, and so in any situation that's a subtraction of two fractions, so we want to find a common denominator. So I'm going to factorize this. So this is x plus 2 x take 1, and so what that tells me is I need to times top and bottom of this fraction by x take away 1. What that's going to do is obviously give me the same denominator across both of these. So this equals 5x add 1 over x plus 2 x take 1 take away 3, or let me write it like this first, x plus 2, but I'm going to times top and bottom by x take 1. And it's at this point that it's important to remember and why it was relevant that x is greater than 1. So x being greater than 1 means, well, first of all, the x plus 2, and the x plus 2 that also appears here, the smallest that is well, it's always greater than 3. So in particular, it's never 0, which means I'm not dividing by 0 in this situation. Now, if you look here, we've obviously got x minus 1. Now, if x was 1, I would be dividing by 0, and if I'm timesing top and bottom by 0, I'm like, well, I can't do that to a fraction. So the fact is, I'm allowed to do this. There's no problems, specifically because x is greater than 1. And while that might seem a bit pedantic, it is actually quite important to take note of that. Okay, so what we'll do is obviously write it with a common denominator, so x plus 2, x take 1. This is 5x add 1, take away. I'm just going to do this in one go, so this is 3x, and then minus 3, lots of minus 1 is plus 3. And then I'm going to simplify the top, so that's 5x, take away 3x is 2x, 1 add 3 is 4, over the bottom, which is x plus 2, x take 1. Which is equal to 2 lots of x plus 2 all over x plus 2 x take 1. And then can I divide top and bottom by x plus 2? Yes, I can, because x plus 2 cannot equal 0 in this situation. Whenever you're dividing by something, you've got to make sure that that thing is not 0. That has always been the case, but it's very relevant at A-level mathematics. So divide top and bottom by x plus 2, and you get the answer that they want, right? So 2 over x minus 1. And yeah, it's still relevant that x must be greater than 1. So this never, actually, we never have a division by 0 problem. Okay, clearly when x gets close to 1, this gets larger and larger and larger, but we never actually divide by 0. Right, so that was 1a, so let me just put that over there, right? B. What have we got? We've got f of x, and we now know what this is equal to. This is 2 over x minus 1. and we want to find f inverse. So what I tend to do is I tend to replace the f of x with a y, and keep the other one, this the same, and then rearrange to make x the subject, which is hopefully similar to how you've been taught. So in this situation, you'll want to multiply it by the x minus 1, expand, and then we want x to be the subject, so all the terms that involve an x need to be on one side by all together. This could be more complicated. You'll have seen questions like this before, even at GCSE, 3-4 mark rearrangement of formulas questions. So the idea in those would be you then factorize and then divide. In this situation, it's much easier because the x's are already all together. So I'll just divide by y. And then what you're supposed to do now is say, right, okay, instead of writing x, I'm going to write f inverse of x. And over here, instead of writing y, I write x. So I get my answer, 2 plus x over x. And then that's the final answer. Now, there's a value that obviously you can't have. X couldn't equal 0. I don't think that's in the mark scheme. I think that this is enough to write. But you should always be on the lookout for issues, right? So I can't actually have f inverse of 0 because I can't divide by 0. So that's part B. Obviously, you can pause the video and go back if you need to. You can also ask questions in the comments or send me an email, or well, those two options. Right, C. Okay, we've got g of x. I'm just going to write it like this straight away. G of x is x squared add 5, with domain x is all real numbers. So notice that g is always going to output a positive number. In fact, the lowest that g of x can actually be is 5, right? That happens when x is 0. Other than that, it's always actually greater than 5. So that's what g is. And we've got a question here about fg of x equaling a quarter. So clearly we have to know exactly what this means. I keep looking, by the way, I keep looking over there because that's where my face is, but that's where the camera is. So fg means f of g of whatever, right? So this is f of g of x. This was something at GCSE. This isn't new to A level. So what we have to do is, well, we have to remind ourselves, I guess, what f is. So what was f of x? F of x was 2 over x minus 1. And we have to make sure that we're putting into f something that is greater than 1. But remember what I just said about what gets output by g. So you're going to put a value of x in to g, and it's going to give you something. Well, it's going to give you something greater than 5. It's certainly going to give you something greater than 1. So x is greater than 1 is going to be okay no matter what x actually is. If that makes sense, right? This is, if you can imagine replacing it like this: f of g of x is 2 over g of x minus 1, right? I'm swapping the x for just a g of x. But now I've got to swap it over here in the domain. But g of x is always greater than 1, so this is why I ticked there, okay? So anyway, what does this actually equal? So this is 2 over, now g of x is x squared add 5, so x squared add 5, but then take away 1. And so this is 2 over x squared add 4. And this is, I guess, as simple as this goes, and we want to set it equal to a quarter. Okay, so equals to a quarter. Now, straight away I can actually see that this would have to be 2/8, right? This would have to be 2/8 in order to equal a quarter. So therefore this x squared add 4 would have to equal 8. We can also show that just with a simple rearrangement. So multiply up by x squared add 4 and multiply up by this 4 and you'll get x squared add 4 equals 8, which is x squared equals 4, which is x is plus or minus 2. Now remember, x is first of all going into g. So x is allowed to be minus 2, because if I do minus 2 squared, I get 4, and then 4 add 5 is 9, and 9 gets to then go into f, right? What would that be? That would be 2 over 8, which would be a quarter, which is what we want. And we can also see that positive 2 being fed first into g, and then the answer getting fed into f would also give a quarter. So this is the final answer to that one. Right, I'm going to end the video and do a separate one for the different questions. Right.